All right. So the way this whole thing starts is you go to samsclass.info, and then at the top there are the workshops, and this one here is securing web apps. So you click that, and this is a structured like capture the flag. So you do a bunch of challenges and you find flags and you can submit them here, and then you end up on the scoreboard. And as you see, a few people have already started doing it, so that's fine. And so first, the main thing people use for securing web apps is Burp. It's the tool people use to find vulnerabilities and earn bug bounties, although I've never succeeded in making any money that way. You have to really be up on all the latest, fanciest stuff to be the first to find vulnerabilities. So what you're going to learn today is certainly not going to get you to the point where you could earn bug bounties, but it is the first step on a path that would show you how to secure web apps. So we'll go through Burp and a few ways to detect and exploit vulnerabilities, then set up your SAML servers of your own on the Linux cloud, on the Google Cloud, and then use Zap. And I run Zap from a Google Cloud server. It's a vulnerability scanner. You might be able to run it from home, but if people cannot run it from my college, a lot of people filter the kind of traffic that vulnerability scanners send out, so I prefer to send it from the cloud. And then we'll use Postman a little, which is a tool people use to test APIs. And API security is closely related to web app security and very important. Then we'll set up Splunk and CircleCityCon. CircleCityCon is we'll set up a vulnerable installation of Drupal, and then CircleCityCon, which is an intrusion detection system to monitor it, and Splunk, which is a log aggregator, the most important one, the #1 SIEM system. If you haven't used Splunk, you should probably focus on that. And then, so we'll set up your own system here so you can watch some attacks come in and detect them with Splunk. And then if you want to learn more about Splunk, this whole thing here is enough for a whole workshop all by itself. I have taught this just as a workshop, and that's Boss of the SOC. So I'll talk about that, but there's a whole series of challenges there where you practice getting real attack data out of Splunk. I've got a few networking projects where you use basic tools like Nmap and Wireshark. There's a couple of basic defenses here that everybody should know: how to set up HTTPS, how to put on CAPTCHAs, and how to use canary tokens. And there's some command injection stuff here, which is how you attack the operating system under a web app. So it is interesting and a fairly common problem, but a lot of people don't include this in the field of web app security. So I put it at the end, and I regard it as optional for this class. So that's a general overview of what we're doing. And let me just start with probably the most central stuff, which is Burp and SAML. And here's some crunching. I'd figure out who to mute if I could. But anyway, all right. So we'll start with Burp. Burp is the main tool you use. So you download and run Burp. It runs on any operating system. And you will end up with Burp like this here. And if you go to, when you first start Burp, let me just close it and start it up again, because it does ask you a lot of stupid questions at the start. So when you run Burp, it will. I found out who to mute. Okay, that's good. I'm getting there. All right. And all right. So you just go through the defaults and you start Burp. And when Burp starts, it is a proxy. And for some ungodly reason, it starts by blocking all traffic. So you have to go to proxy intercept and turn this off, or you'll have a very hard time using it. In options, you'll see that by default, it's a proxy listening on 127.0.0.1 for 8080. So that means you can redirect all web traffic through it by just setting the proxy in your browser. The browsers have different panels for this. What I always do is I choose one browser just to use for Burp, and it's one I don't use for other purposes, because that way I can do normal surfing without Burp getting in the way. So if I go here, this is Firefox, and you can set the proxy by just going to Preferences, and then you can search for proxy here. And when you go to Settings, you'll find you can set it to a manual proxy of 127.0.0.1 is what you want. Now, what I did was I installed an extension just to make this.
That's what I was going to say. I like to use Foxy Proxy.
Yeah, Foxy Proxy is just a somewhat handier way to do the same thing. So you can easily turn it off and turn it back on. But when you are going through Burp, then if you go to an unencrypted website, like this one, ad.samsclass.info is one of mine, then it loads this page. And if you look at history, you'll see, should see the requests that did that. Yeah, okay. Now here's some other junk, but here's the request that did that. So the very simplest thing you can do with Burp, which is important if you are not familiar with web design and such, is to see the requests that load a page. This is a very simple page. It sent a GET, which looks like this: get the default page from this host, and the rest of this stuff doesn't matter that much right now, although the cookies are going to matter to us later. Then you get a response. The response comes down here. Web responses always start with a status number, which tells you whether the request worked or not. 200 is okay, 404 is an error, and there are others. And then you get information about the server itself, and then you get the HTML that builds the page. And in Burp, you can look at the raw response, or you can have the headers put out in a little table, or you can see the thing in hex if you want to, or you can see just the HTML the way you would if you went to source code in your browser, or you can go to render, and it will try to render the page here. It's not as perfect as a browser, but it is pretty convenient for looking at web pages. Most of the time we're going to use raw, but sometimes you use those other tabs. So I sent a request, I got a response, and you can watch every request and response, and you can do everything cool in Burp. For example, you can repeat a request. This is extremely useful. If I wanted to modify something about this request, I right-click here and send it to the repeater. And now I can go to the repeater, and it shows the request, and I can edit this. So I can send it here and get 200 okay. And if I were to try to load a different page, like say a flag here, and go, now oh, there's a flag there. I remember putting a flag there. Probably somebody else did. Anyway, that's not a project we're doing today. But by the way, it's worth mentioning, my servers are running all kinds of vulnerable junk, and they get hacked all the time. So other people keep putting random junk on my server, which is true of everybody else's, but mine, I intended for it to happen. Anyway, so you can modify and send requests here. Anyway, let me go back to my instructions. So this is just the instructions to get you to there. And once you've got Burp data going through, then we can start looking at some example traffic. So I'm going to move the instructions off this screen here, although you've got the instructions, so you can do this. And all right, here. So I'm going to go to Hackathon, http://Hackathon. Okay, hackathon.samsclass.info. This is a product, I think it came from OWASP. Somebody wrote an imitation of Amazon just for practicing hacking. And so it's like Amazon, except it's got all kinds of vulnerabilities in it. So I've loaded this. And if you go to proxy in history, you can see here's the request loading the Hackathon page. There's the request. And there's
what did you load exactly? Do we need to get that?
Yeah, it's in the instructions. You'll
okay, I'm looking at the instructions right now then.
Yeah. So you'll find here, if you go to the first one, W510, this one here, it's in there showing you where to go. And the point of this thing is, okay, so that's the first thing, is just to get up there. And then you can try sending encrypted traffic through Burp, which may work on mine, but it probably won't work on yours right away. So there's an encrypted site. There's quite a few, and I'll just use this one. I made an encrypted version of Hackathon. Okay. And when I did that, it loads. Now, you might, if you know about HTTPS, you should be rebelling at this point. The only way Burp can read that traffic is my web request went to an intermediate proxy, which then went to the server, and the whole point of HTTPS is to stop that from happening. If somebody in the middle is trying to sniff our traffic, you're not supposed to be able to do it. The reason why this worked is because I've imported the certificate into Burp, which you have instructions to do here. You can take, I get my thing to move here. I'm thinking.
I'm sorry. Can you give me that number one more time after that? You said 5110 or W510. Okay.
Yeah, this one here. Yeah. All right. So if you have just set up your burp, you will not be able to connect to a secure website. You'll get a warning here, which is what you should get, saying you're HTTPS and there's a man in the middle sending a fake certificate. When you send secure requests to Burp, Burp makes up a fake certificate and sends it back with the wrong public key so that you will encrypt traffic and Burp will be able to decrypt it and then forward it to the real server. And that's exactly what you're not supposed to be able to do with HTTPS, so your browser will correctly prevent that. And then if you go to the advanced and accept the risk, then you'll be telling Firefox to trust Burp. So if you do that, then it will allow that middle device to see what you're doing. All right, so let me go to this particular page I'm supposed to be looking at here, which is this one, copy link address, and go back to Firefox. All right, so here's a simple login page. And if you can see, there's more requests going by as it loads. And all right, let me find my instructions. My pages are kind of a mess, but we will cope. All right, so I could capture the web request. All right, and I'll just demonstrate how to capture a request if you want to. So if I'm just trying to figure out how to get all these windows out of my way. All right, so I'm going to log in here. I'm going to put in name and password. And if I just log in, it's going to go here and tell me that was rejected. So I can go down here and see that happen. Here it sends a get. And if I expand this pane, you can see it's putting the name and password right there in the URL. Now, this is not a recommended security procedure because that URL might be saved in a server log or a favorite. However, it is sent over the internet encrypted with HTTPS, so it's not exposed to just trivial sniffing. But anyway, that's the request. Now, if I wanted to modify that request, I could do it. I could do it either by sending this to the repeater, which is the easier way, or the more difficult way is get ready to log in here, name and password. Then you go to options and turn on intercept, which I mentioned before. Intercept is powerful but difficult to use. Now when I log in, figure out how to get rid of that. And there's the participants, okay. And as usual, by the time I'm ready to figure out who to mute, I can't. Anyway, so, all right, what it's done is made a request and the request has been stopped. It's about to ask to send this password up. So I can forward that page, but I can modify it. So I can change this to say password 2. And then I can forward that request and it will go to the server. And here comes another request. I can keep forwarding them, or I can just turn off intercept so they all go through from here. And then I'll get the result in the web page. Anyway, that's what you need to do. And we'll do that for more valuable things a little bit later in the next project. I'm going to get back to my instructions, which have strangely vanished. Okay. All right. All right, so then there's repeater. There's some projects where you practice using repeater, which I've already shown you. And then there's some challenges here, like to buy an iPhone. So you can adjust any request. This is a very common problem where people have, for example, let's do the cheap phone one. Here's a form that sells phones. So I need to load this page in Firefox. So let me go there. Okay. All right, there's this page with this project, and the forms are just right on this page. So down here someplace is a page that sells an iPhone. All right, well, here's a simpler one. It's going to let you put in 2-character field for state. So I can put in California and submit it and continue. I don't care, but it's not encrypted. Okay, and it doesn't like that because the state name is short. If I go to history, here is the post that posted the state. And if I want to send a longer state, I could go back here and try to type in something longer, like come on, X, Y, Z. It won't take the Z. That field will not take anything else. And that's because if you view the page source and find the state field, let me just use inspect instead to get down to it. I'll highlight that and inspect. And that should show me the code around that.
Hey Sam,
Yeah.
I'm still having trouble finding that original screen with the instructions on it. Where from your main page do you click on? I clicked on the web app thing, then it just brings up like
Right.
links to click on.
All right, you go to samsclass.info and then securing web apps
I clicked on that.
and then 510 right here.
Oh my goodness. Sorry. Go ahead.
I'm glad, no, but I'm glad you're seeing it because there's no point anyone suffering at that level.
I had those links. I just didn't realize that what you clicked on. Go ahead.
Anyways,
Sorry to interrupt you.
That's fine. No, don't worry about it. That's why this is not a canned thing. So let's look at page source because I can't figure out how to make that inspector work. And state. All right, there. This is what I wanted to show you. This is the most common problem for web vulnerabilities, is that the web developer does not know the difference between code on the server and code on the client. So the web developer will say, I only want a 2-letter state. So in HTML, they will just put max length equals 2. Another thing they'll often do is have a JavaScript script that checks to make sure that the thing passes some kind of validation, like only numbers in the numerical fields and such. The problem is this is enforced on the client, and you cannot trust that that has really happened. They will think that they can't put in a longer name because they only give you 2 letters here, but you can put in a longer name by just using Burp. I can take this request, which contained a 2-letter name, and send it to the repeater and just make that longer. And now when I send it, it's going to tell me I did have a long name, so you get a flag. So that's the point. This is the fundamental problem, and you'll see this happen all the time. You can often take a website that gives you a free gift and just get another gift and another gift. All kinds of online polls. You, like Anonymous did this, you can make 1 million votes for someone. They changed Times Man of the Year to be somebody like Milo Yiannopoulos or someone ridiculous. I mean, because all you can just keep changing it, change the requests you appear to be different. That's why it's, the fundamental problem is you control everything that happens on your machine, and you can grab the packets on the way out and alter them with no regard for what the web developer thought they limited you to doing. So here's a really common one. You can buy an iPhone and the price is fixed. You can't change it, but you can change it in Burp. And so nobody should trust a price that came from the client. They should only trust the price that comes from the server. But many web developers make this mistake. So you can buy something and change the price, change the quantity. Yeah, so that's a very common trick. And that's the simplest thing you do with Burp. And there's
So
used to be a
when you're watching this, how do you tell the difference if it's a client side or server side? If you're the one like us looking at it.
If the client side you can see, if you go to view source, you'll see HTML code and JavaScript code, and that's running in your browser. The server side, you can't see the code. It's sitting on the server in ASP or PHP pages, and all you can see is the results. So we'll have, we'll see those come up. So, but to be fair, it's not that people are just stupid. Like beginners in security are always like yelling at developers and managers, you guys are just idiots, you didn't do this simple thing. But there's usually a reason. And the reason is web development happens in a big, complicated ecosystem of servers. And the web developer often doesn't have access to all the other servers. So they try to code in a way that will not depend on other services. So they often do things that are sleazy for good business reasons. But anyway, you should know the risk. And all right, so that gets you just the bare minimum of Burp. And let me go back to the next one. I'm going to go back to, okay, I was in the right browser. Okay, I'm getting a little confused with all my browsers, but that's life. All right, so here, I go back to the main page, and I want to show you this SAML one because this one is fun. This security assertion markup language lets you send security information over the internet. You make a blob of data, and in that data it will include information like, I have logged in, I am Sam, or I have logged in, I am the administrator. And it sends this ID card along with you. This is extremely useful because this means you can let somebody else do your login. Like almost everybody doesn't bother to handle passwords anymore. They just let you log in with Google or Facebook. So even though my site is something else, you click a link, it goes to Facebook, they log in, I never see your password. Facebook sends me a card back that says, okay, this person convinced me that they have this name. So believe that they're that person. And that's what almost everybody does. And here's how it works. So I made a simple page that does this called SAML. That's samsclass.info. So if you go to this page, I am now at sp.samsclass.info. And the point is, this is the service provider. If you want to make some kind of website or game or something, you're the service provider, and you don't want to handle logins. You just want to provide some third service. So that's the service provider. So if I want to log in, I click here, and I move over to the identity provider, which is a different server, IDP. And here I put in a username and password, like user1 and PWD. At the identity provider, then I log in, and the identity provider sends that data back to the service provider, and the service provider now knows I'm logged in as user one. And that's fine, but for this game, you got to be admin. So the trick, you do not know the admin password, but you want to trick this system into believing that you're the admin. And the fundamental weakness here is that typically the identity providers are strong and secure because they're somebody big like Google or Facebook. They probably are
Aren't
not.
they using something like OAuth challenges?
What's that?
Like, aren't they using something like OAuth challenge?
Yeah, they could be using,
Okay.
OAuth is what they should be using, although people often implement it incorrectly. Yes, OAuth. So OAuth is one of the common systems to do this, where you let somebody else do authentication, and then they just tell you that somebody has proved who they are. But what often happens is the service provider does not implement it correctly. So that's what's happened here, and it was a very common problem. And you can exploit SAML vulnerabilities very easily with Burp. So let me put this in Burp. This one right here. I want to go to this one. Copy link. All right, I'm going to put that in Firefox. Okay, so if you go there, all right, so here's my challenge page in Firefox. And here's my Burp. And I'm going to just clear all this old stuff with clear history, yes. And then I'm just going to reload this page. All right, so it's a simple request to the service provider page. That's all that's happened so far. So I'm going to do a login with user1 and password. So I go here, and now I type in user1 and PWD and log in. And now I have the whole process of authentication here. So I loaded the service page. I redirected myself over to the identity provider. I sent my username and password there and came back. Now, let me check my instructions to stay on track here. All right, so here's we've talked about all this. And by the way, I added an extension to my Burp. Burp, like Firefox, has all these extensions you can add. And there's one just for this purpose called SAML Raider to attack this language, SAML, that we're attacking. So when I'm done, I want to follow the process, the identity provider, and then I want to look at the response tab to the one that sent your data. Okay, let me see if I can get here. All right, so this is the post that moved me over to the identity provider. This is now sending a SAML request. And one of these someplace is going to send there. This is the one that sent my username and password. Username and password went there. So when it did, the response after it accepted that was to send me, it's going to send me there, a SAML response here in this. And that's what this blob of junk is. this giant blob of base64 encoded text is my identity card. That's the SAML response. And what that is a whole bunch of data that the identity provider has provided to prove who I am. And when I go back to the service provider, that's what I sent up to the service provider. And you can, the purple lines are ones that SAML Raider understands. And if you go to SAML Raider, it will decode them for you. So that whole blob of junk was just base64 encoded. And here's what it is. It's a whole web page full of data. It includes all kinds of headers and cryptographic signatures and certificates to verify it. And at the end is the active ingredient for us, is what all this junk proves. And what it proves is my name, and there, it proves that I am user 1 and that I have this email address. So that's what the point of this ID card is. And it has cryptographic signatures to prove that. So I can now try to twist this. And let me just check my instructions to stay on track. All right. So I'm going to attempt response forgery. So I go here and log out. Now I turn on interception here because I'm not able to modify history. So I have to intercept traffic, and this provider is secure enough that I can't just repeat a request. Proper requests have anti-CSRF tokens, so every request has a different random number. So if you copy a request onto some other system and repeat it, it won't take it. That's what you should have. And so this is smart enough to have that. So I'm going to clear this old stuff. I guess it doesn't matter. I'll just turn on intercept, which is here. And then I will log in. Okay, so this, now I have to forward until it grays out, forward, forward, forward. Now it grays out because it's waiting for something to happen here. Now I'm going to put in user 1 and PWD and log in. And now I get a request here that has been blocked by the proxy. Now, this has raw params and hex, but it does not have a SAML Raider tab. So this doesn't contain SAML. So I want to forward so that this one has a SAML Raider tab. Now, this one is the one we want. This SAML response here is the junk we want to mess with. And we will go to the SAML Raider tab to see it. And now I can change it. So suppose I just tried changing myself to admin here. Now, this should not work because the client should be checking that all that cryptographic stuff up here is correct. And of course, all this junk, signatures and stuff, is not going to work now because I modified the data. But it's possible that the client is ignoring all that and just looking at the administrator. So I'll turn off intercept and see what happened. And the answer is I got busted because I wasn't at the service provider, I was at the identity provider. And the identity provider could tell that this was no longer cryptographically valid data. So I got busted. All right, so let's try it again. Go back and log out and get back to my login page and put on interception again and put in username and PWD and log in. Okay. And now I forward this one. Okay, and this one is now going to the service provider. It's got the SAML. So what I'm going to do now is I'm going to remove the signatures entirely and then change myself to admin. And this is and now it's going to work. Now I get in. And the reason is the client was stupid enough to not verify the signatures. If the signature was there and it was wrong, they would bust you. But if the signature was completely absent, then that would fail. And this might sound like you couldn't make this mistake, but I, in fact, have made this mistake many times. Students found out when I started doing these CTFs that on quite a few of my pages, if you just leave the answer blank, it will accept it as the right answer. It is pretty easy when you're writing code to say, if answer equals correct answer, do this. But if one of them is absent, that creates an exception and has an unexpected consequence. Anyway, so that's the SAML challenge. So start doing these things, and I'm going to stop this recording and then see how people are doing on the scoreboard to decide how to move forward. So let me find my recordings.